Number 2 is the same as number 1, but West Area B, where the dunes are even a little bit further east. Oh, I didn't give you the areas, did I? You don't know what I'm talking about when I say Area B. Oh, I'm so sorry. Well, this is not going to be that easy then, but I have the next slide I can show you on. This is a very early version drawn by engineers, so I apologize for how ugly it is. But you can see the levees stay in place to Culver, then the levees are removed, and there's a meandering creek to about, in this picture, to here. This protects the dunes area, and we have different levels of intertidal marsh all the way to here, which is uplands, and this would be actually an earthen levee. So not a concrete levee that's about this steep like we have now, but an earthen levee with a very gradual slope that provides habitat in itself and is a transition zone for plants and wildlife. Also will accommodate a certain amount of sea level rise over time so we don't end up with a big pool sometime in the future. So this is alternative 1. Alternative 2 is very similar, but the levee would only be taken out to about here. So the western portion here would not have wetlands restoration occurring. I'm going to have to go back and forth, so forgive me. Alternative 3, same as alternative 1, so it looks like this, but the whole southern levee stays in place, and this levee either comes out or is partially removed to allow a meander through. And in all of these first 3 alternatives, a lot of grading has to happen in this section to remove, I don't know, probably 600,000 to 1 million cubic yards of fill. It's remove or move around. So a lot of the fill that's here would be pushed back here to make these earthen levees. And like I said, they're going to be very gradually sloped, so it's going to take quite a lot of dirt. These are also earthen levees. So in alternatives 1 and 2, earthen levees going up to a bike and walking path at the top, very wide levees. So again, a nice gentle slope looks like an old dune probably. Alternative 4 will leave this levee in. This doesn't change much, and up here we have only upland restoration. Number 5 would not look like this at all. So I'm just going to go off that page. Number 5 would not move around any of that fill from the northern half where it was plopped when they dug out Marina del Rey. Instead, it would involve minor earth moving that can be done with very small tools, and no relocation of the gas facilities. Basically, it would be taking out invasive species and planting native plants in various places. Alternative 6 is no federal action. That means nothing that would affect a wetlands or a levee. And the levees aren't just the concrete things, it's the backside as well, and stuff like that. So no federal action means there could be a visitor center. We don't know, I don't know exactly what they're examining for a visitor center for alternative 6, or even the location of it. And then alternative 7 is no project at all. So the next steps, and the time when you will be able to see these alternatives, much better illustrations and much finer detail, like where will the gate be, where will I park, where will the path go, where will I rent a, I don't know, kayak for the estuary or something, I don't know. The places where you'll be able to see all of that information is in the draft EIR, and this is a process for the EIR. We had a scoping meeting. We are writing the draft EIR. It says EIS, EIR, because it'll fulfill federal and state requirements, NEPA and CEQA. There will be a review period for the draft EIR when everybody gets to examine it, ask questions, and submit their comments to the lead agency, the Department of Fish and Wildlife. That will come out, these are in italics because I don't actually know when it will come out, but my best guess is spring 2014. Then there'll be a long comment period. It'll end sometime in the summer of 2014. There will be a response to comments, and then the lead agency, the Department of Fish and Wildlife, can, at that time if they wish, certify the final EIR, EIS. And then they get to apply for their permits to do the actual restoration, whatever they decide, based on the results of the EIR, is the best restoration for the Ballona Restoration ecological reserve.
Already.
Thank you.
Dr. Strauss, are you ready?
I am.
So I'm going to be speaking to us tonight, revisioning the stewardship of Ballona Reserve Ecosystem Services as a tool. This is a mouthful.
I'm sorry. I can't help
Urban
it.
wetlands, and Dr. Strauss came to LMU
Very end, I
years
guess.
ago.
4 years ago now.
4 years ago now?
Yeah.
Where did I don't know. I'm real sorry. Sorry. You served as
Maybe some people feel like it's their year. They're talking to my team.
Sorry about that. Dr. Strauss serves as Loyola Marymount as president, professor of ecology.
Yes.
Yes. Executive director of the Center of Urban Resilience, Cures. Yes. And director of the graduate track in urban ecology with collaborative research specialties in animal behavior, endangered species management, urban ecosystem dynamics, and science education. He is the founding editor of a web-based peer-reviewed journal, Cities and Environment, which is funded in part by the USDA Forest Services. His research includes collaborative long-term studies of coyotes, white-tailed deer, crows, turtles, and other vertebrates, with a specialty in understanding wildlife in urban areas and appropriate management responses to wildlife problems and zoonotic, all these ecological terms. Thank you. Where was I? And disease. His work also includes investigating the role of green space in urban forests and supporting of healthy neighborhoods and how those features can be used to improve science education in underserved neighborhoods. May we welcome, please, Dr. Strauss.
I'll try and move quickly tonight because I know we've got a lot of information to go through. And I just want to begin by saying what a delight it is to be here. There's some faces that I recognize, some faces that I'm meeting for the first time. And these are complicated issues that we're considering and a complex landscape we're walking across. And I have to say that as challenging as these problems are, it's a delight to be in a community of people who are thought leaders for the region they live in and come with deep passions about what they believe. And so in the conversation I want to have in the next few minutes, I want to talk a little bit about urban ecology, about ecosystem services. I'm not going to talk much about the Ballona wetlands because we've had such a wonderful introduction from Shelley, who knows this so well. And then I want to just frame this in the context of what are the tools at hand that as an urban ecologist we might apply to thinking about environmental interventions like an educational center. Here's one of the larger vertebrate residents of the Ballona wetlands. That was a coyote that we took a photograph of a couple years ago as we were cleaning out some of the old bird boxes there and preparing them for the next breeding season. So I'd like to provide what I hope is a deeper understanding of the frontier science that I work with and think about it as a frame, as a contextual frame for the kind of decisions that we will be making about this wetland system, given the fact that we're all stakeholders in this decision. I love this image to start talking about Los Angeles because Los Angeles is a microcosm of the kind of density we see here. You know, this is an extraordinary image. This is a satellite image at night. The light spots represent the accumulation, the aggregation of lights that are created from this incredibly technical species called human beings that have reorganized themselves in a relatively small amount of time from being primarily an agrarian species to one living at very, very high densities in urban areas. And so these lights represent the aggregated light of cities generated in North and Central America at night. Along with that change in demography, it was only 3 generations ago that most Americans were involved in farming. And now we have a reality where only about 5% of Americans are involved in farming. And we also see, and this represents a different kind of aggregation, but one that is as socially profound as choosing where we live. It has to do with choosing where we eat. That's a compilation of where the 13,000 McDonald's restaurants are located in North America. And I bring that up because it represents a profound change in the way we fuel our metabolism. The average American gets more than 1/3 of her calories from takeout restaurants. And that represents both, and it may actually be more appropriate to say his calories, but so his/her calories, takeout restaurants, but it represents a profound change in the demography of the structure of work in the American family. It's a profound change in the way that we spend our money on food, and it's a profound change in the way that food is distributed. On one side, it's an extraordinary technological achievement that such a large number of meals can be generated in the public sphere on a daily basis, so inexpensively. On the other hand, there are environmental costs, there are deep behavioral, metabolic costs to those kinds of decisions, and as stakeholders, especially the young people that I work with in underserved neighborhoods and schools here within the Los Angeles area, who are expecting to live to be 100 years old or more, the kind of decisions we make about our food are as intimate and critical to the ecology of Los Angeles as the decision we make about how we use our land. Because the integration of social and physical ecology is almost complete now within the field of urban ecology. So what do we mean when we say the word urban? If I was to interview folks here, you'd all come up with a different definition. But coming out of one of the largest of the urban studies that's taking place now in the United States, there are about 16 of these urban research centers funded by the National Science Foundation. I still serve as one of the principal investigators in the Boston study, but our focus now here is in Los Angeles. There's a broad meaning and a narrow meaning, and the broad meaning really takes into account the entire petroleum commuting network that supports an urban area like Los Angeles. And the narrow meaning is this really strict sense of the densest areas. And given the time we have tonight, I'm going to flip back and forth between those two. So what do we mean when we talk about urban ecology as a science? It's an interdisciplinary science. It uses the tools of both natural and physical sciences and the social sciences to study the legacy of cities and understand that legacy as a way to think about resilience. And if there's one thing I would hope to do tonight, is to help you think differently about the word restoration. Because if we could start again with framing the question of how to manage these incredibly fragile and complex landscapes that we've chosen to live next to, the word restoration is not terribly helpful. Because what are we restoring to? What is the point at which we felt was the appropriate landscape, the appropriate point in time in the natural ontogeny of landscapes? What point are we picking? So really the appropriate term is transformation and reinvention, asking a series of metrics. And given the fact that urbanization is the dominant demographic trend, and it's the most important component of land transformation we have on the planet right now. We were moving more soils and impounding more water than most of the natural processes that happen on the planet. And so and although cities only take up about 6-7% of the world's land cover, we've picked the best areas, the most productive areas to put our cities. Although we no longer often capture the food and the power that those cities originally provided, which tended to be water power, and food sources coming from the soils and from the near shore. We now have to import all of that. But we've chosen the most valuable locations ecologically to put our cities. And that results in very large concentrations of often underrepresented populations. And it's one of the great social challenges that I argue is deeply ecological about the distribution of resource and the access to resources that exist when we create a community like Greater Los Angeles. It's 14 million people. Remember, I come from Boston. That's where I cut my teeth, living next to a 3,000-acre salt marsh on Cape Cod that in many ways looked like it did 200 years before. And now I have the great good fortune to be here where you have the entire population of New England in an area smaller than Rhode Island. It's absolutely extraordinary that you've packed 14 million people in here. And on a daily basis, your carbon footprint is about as low as any city in America because of the relatively mild climate and some of the important decisions that you've made as Angelenos. It's really an extraordinary thing to be proud of. And the fact that there's a conflict around these decisions is exactly right. These are tough decisions. And I'm going to introduce the idea of wicked problems. There isn't a single right solution. If there was, we would have been there a long time ago. This is a complex, iterative process. And so we have this opportunity to re-envision, or revision for short, This approach to engaging underserved stakeholders and reimagining the boundaries of what it means to collaborate and engage disparate communities in the decision. And so when we talk about something like a 600-acre remnant of what once was a green jewel in Southern California, we not only have to ask the question about what are the right interventions for that system, but who's going to take part in that system? How do we make that system accessible? What are the services that we need that was never considered at the time in which some of these initial management decisions were made about how do we intervene in these kind of wetlands? So a scientist, ultimately, depending on, it's just all about scale. We're measuring diversity. And when you heard Shelley talk about all these different measurements that were taking place to do the assessment. We're interested in the nature of biological and ecological variation, and we lump that into the context of diversity. But in urban ecology, it's framing a different kind of question. Because what we're really interested in here is diversity, not for diversity's sake, although that is important in the context of basic science. But in the context of making more livable and resilient communities, what we're interested in is the relationship of biological diversity, or what are the systems we measure out in those wetlands? What do they contribute to the ecosystem services that we rely on? The cleaning of the air, the replenishment of soils, the movement of water, but also, as we'll get to in just a moment, what are the social components of what healthy ecosystems need from their green space? So ultimately, the ecosystem services contribute to something we call ecological resilience. You know, when I started my training as an ecologist, which was the pre-computer era, I typed my proposals but used the computer for my dissertation. It had a 30 megabyte hard drive. I thought it was amazing. That won't open your garage door now. But at the time, it was enough. We were thinking of ecology as reaching these stable states. You may think of these terms you may have heard, like climax forest, or things where ecological systems would change, they would reach some steady, stable state, and our great challenge as stewards was to manage that stability. Well, that came from the fact that the blinders we had was the length of our sample size. I mean, a basic unit of ecology is 10,000 years. We're only beginning to understand the cycles and metacycles and the nature of disturbance like fire and earthquakes and floods and landslides that are actually critical to how ecosystems function. We're having to redo so much of what we learned. And it's the resilience of ecosystems that are critical. It's that capacity to persist and adapt and transform in the face of shocks. And so in a place like Southern California, 14 million people is a big shock. So you got to manage a system differently than you would have managed it in a place that had 2 million people or 100,000 people. So ultimately, ecological resilience is going to help us buffer global environmental change. This change is happening so fast that it's forcing us to rethink the very plants we put in, the very structure of the landscapes that we're considering, because the dynamic changes are happening much faster than we had predicted. They are in many ways anthropogenic in nature. They are forces that we've accelerated because of the technology and the movement of carbon from areas that were hidden underground to burning them and releasing them into the atmosphere. They are natural processes, but we move stuff around, and as a result, our climate is shifting. And ultimately, these activities, these transformations or interventions, are forcing us, hopefully, to live within planetary boundaries. Because this is the only real taxi cab we have to journey through the universe. We have some incredible technical skills. You know, we put 3 people in a can, sent them to the moon, brought them back. They're alive, they were fine, but that's not an intervention that works on a global scale. And because remember, think of the challenges we have, and we're the wealthiest nation on the planet. We don't even have the biggest cities in the world. We don't have the largest populations in the world. Other parts of the world are struggling with bigger cities, with many, many times more levels of poverty, and they're trying to get it right. This is the great potential we have as a nation in the 21st century, is to be thought leaders in the future of resilient and sustainable cities. It's an army of ideas that will transform the world and lead to resilience. Most of you know ecosystem services, or at least you've heard of it, and I want to jump past this, but some of the basic ones are that we rely on nature for purification of air and water, mitigation of droughts and floods, detoxification and decomposition of wastes, pollination of crops, dispersal of seeds. These are all interesting, right? Because in the back here, you say, well, yeah, we can do this technologically. Most all of these things we do additionally add technology to, but it gets a lot more expensive to do it this way. And so when nature can do these things for us, then we offset and enhance costs, enhance our economy, and improve our resilience. And these are the physical factors. There's a whole suite of social factors that are important as well. Which leads me to an example. Our lab does a lot of work with urban predators. Urban predators, in this case mesopredators like outdoor cats, are a significant ecological impact and a really, really complicated issue in a place like Los Angeles. Depending on whose data set you look at, there's somewhere between 600,000 and 1.2 million outdoor cats roaming Los Angeles that are killing some huge number of birds. We don't understand fully the impact of these kind of predators on a system. What we do know is that humans, as long as there have been cities and aggregations of humans, there have also been domesticated animals. And so the relationship of humans to urban areas, to urban ecological components also include this range of animals. We know that cats are predators. They live at ultra high densities in urban communities. We know that this human-cat coexistence predates urbanization, and it's incredibly complicated management, regardless of the solution choices that you make. I call this, as do other folks who work in this field, the very essence of a wicked problem. It's another phrase I hope you'll remember tonight. It's wicked not in a biblical sense, but it's wicked in the sense it does not yield itself to easy solutions. Look, everyone who's taken time to be here tonight because of where we live and the time and place and the education you've had, we are all extraordinarily privileged to be sitting in this room tonight. So you're all bright, you're all concerned, you all frankly give a damn, and so you're here. And if we sat down and you read all the available literature, which there's never enough, you analyzed all the data, which there's never, ever enough, you could all come up with different solutions to the feral cat issues in Los Angeles, and you'd all be right. And to the other folks, you'd all be wrong. Because there's not a single end game that is a metric that is a single measure of success. And most of the important decisions we have left in the environment are like this. They're wicked problems. So I'm sorry to glaze you over, but this part's also important. Here's the classic world of ecology. We go out and measure structure, and out of that structure comes function. And out of that function comes ecosystem services. And these services are important to human outcomes, and they're important for what we understand, what we believe, and how we structure our institutions. That's sort of obvious to everyone but scientists. And so we had to be told this by the National Science Foundation, which funds the bulk of our work, to say, look, unless you're creating research questions that connect both sides, both the social demands of healthy ecosystems and the physical demands through this network of ecosystem services, we're not going to fund you. And so this helped to dramatically transform the way in which science is currently being done. Remember, in the communities you went to school, typically these folks were in a different college at the university than these folks. Different language, didn't talk to each other, didn't go to each other's seminars, tried to avoid each other as often as possible. Now, if we don't work together, we don't get funded, we don't make progress. It's a wonderful change. So it then presents to us, here's another layer in the cat story that makes it so interesting. So this is a frame grab of a radio telemeter coyote in Boston that was part of our long-term study on coyotes. And she's a young mother carrying a cat back to her den. And this is happening all across cities in America, all across suburban areas. And this creates a sort of a horror when people see it. Creates a horror when I see it. I've had 23 pets in my life, mostly dogs, but 2 cats. And you see something like this and your response is, we need to get the animal control officer out there. We need to control this. This is horrific. How do we trap this coyote and get rid of it? It's complicated because, of course, when you trap an adult male coyote that holds a territory, you take him or her away, you then get 2 more young ones move in, so like in Fantasia when Mickey's breaking the broom up and suddenly he's got a lot of little brooms around. It's a complicated system. But as you look at this more closely, it turns out coyotes don't actually eat that many cats. How do we know? You gotta look at a lot of coyote poop, and you look at the cat hair and so forth. But what's interesting is when coyotes are in urban areas, they change the behavior of cats. They change the behavior of cats big time. Because if you're a cat, you really don't want to run into a coyote. So you hunt less. If you hunt less, you kill less birds. If you kill less birds, you bring less food back to your den, and you raise less kittens. And if you raise less kittens, you have less adult kittens. And you create a pseudo-normal predator-prey relationship and trophic dynamics, the way that energy is supposed to move through an ecosystem. And these guys, if I had to vote for them, they're a net ecosystem service. Because they're much more efficient at managing cat populations than we are. Despite our trap, neuter, release, despite our spaying efforts, despite all the kind of things, despite the euthanasia we do, these guys are better at controlling cats than we are. Because that's what they do for a living. So we also know that when we get cities right, this is the really cool part. This is the part that makes you hopeful, despite the conflict that we all go through every day. The conflict, of course, is trying to lead to something hopeful. There's been some great work by a lot of folks that's more recent, but I love to go back to the first work of Francis Quo, their husband and wife team, and Bill Sullivan at the University of Illinois at Champaign-Urbana. And they looked at relatively underserved and poor urban communities. And they looked at those communities that had green space and those that didn't. They began their study in Chicago, in the Cabrini Green area, and expanded from there. And what they found was extraordinary. That even very underserved and poor communities, if they had green space, and if they had access to green space, there were lower levels of fear, less violence and aggressive behavior, fewer reported crimes, more self-discipline for girls measured primarily as teen pregnancy rates, reduced ADHD symptoms, better neighbor relations, leading up to this idea of enhanced social capital, this fertile ground for stakeholder engagement. So people are now engaging around something that's meaningful and